All right, so let's go through this first example, talking about a couple of things. First, we need to determine the transformation, and then we're going to talk about the idea of what does it mean to be distance preserving. But before we get started, we need to make sure we understand some vocab. The pre-image is the first image that you start with. The image is the second one. So this is what happens to the pre-image after you do something to it. So we're going to transform this first shape up here, and then we're going to end up with the second shape. The second shape will be called the image, okay? So what can I do to this arrow on top to make it look like the arrow on the bottom? Well, this arrow is facing the left. I can rotate it first up, and then I rotate it one more time so that it will be facing the same direction as the one on the bottom. So this could be a rotation, right? It's a turn, but the math term is a rotation. Or the first arrow, the pre-image, is facing the left. I can just pick it up, flip it over, and it would be facing this way. So a flip is called a reflection. Both of these are examples of what type of transformation occurred, okay? Now we need to talk about the idea of distance preserving. Distance preserving means a couple of things. The first, common sense way to know if a transformation is distance preserving is the shape still the same size? So this arrow up here appears to be the same size as the arrow down here. Pre-image looks the exact same size, so that's a good indication that yes, this is going to be distance preserving. But in math, we've got to be precise. And it says distance because they want you to measure a distance. So before we can do that, we need to actually have 2 points that we can measure. So I'm going to change the color because it's getting a little crowded. But I'm going to call this point A and this point B. I'm going to use my protractor and I'm going to measure this in centimeters. Sorry, you can't see that on this slide. But when I measure it, the distance is 2.6 millimeters. Now that's on the pre-image. I need to measure the same distance on the image to see if it's the same. So I come down here, I call this A prime. Prime lets you know it's the second or the image, and B prime. So I measure it again with my protractor and it is exactly the same, 2.6 millimeters. So since I measured one area on my pre-image and I measured that same area on the image and I got the same distance, this is distance preserving, okay? So we're gonna write a definition for distance preserving. Distance preserving. So all it means is the distance between 2 points is the same in the pre-image and the image. Okay, so that's the math definition. Your common sense definition that you ask yourself is, are these images the same size? They're the same size, it's distance preserving. When you're writing it out for math, you're going to tell me the distance between A and B is the same as the distance between A prime and B prime. So I'm going to write that down here so that you know how to write an answer on an exit ticket, for instance, to get full credit. So how do you know this is distance preserving is the question. The answer is the distance between AB, and I put this little line on top to show I'm talking about a line segment, is the same as the distance between A prime, B prime, and then I'll just put what it equals, just so I can prove to Miss J that I actually measured it. Period. Done.